Here is my 5th DER of my grade 11 year, a Breadboard 555. Before beginning, here is some background information. The 555 is one of the most popular and commonly used ICs of all time. The IC timer was designed by a man named Hans Kaemsend in 1971 and is also commonly found in thousands of electronic devices, from the rover recently sent to Mars named Perseverance to commonly used kitchen appliances. This is a direct result of it being a highly stable and integrated IC that consistently produces accurate time delays and oscillation. Now to my project. The Breadboard 555 consists of 11 3904 NPN transistors, 9 3906 PNP transistors, 10 4.7 k ohm fixed resistors, 3 1 k ohm fixed resistors, and 2 10 k ohm fixed resistors. The project alone can be split up into 4 main sections: the trigger comparator, the threshold comparator, the flip-flop, and finally the rest of the circuit. For sake of complexity, I will be explaining how the breadboard IC works on a graph I drew up and then show where it can be found on my circuit. First off, a comparator is a circuit element that compares two different voltages and inputs, a high or low, depending on if the positive lead or negative lead has more voltage attached to it. In the Breadboard 555, two comparators are used, named the trigger comparator and the threshold comparator, both of which wire to the flip-flop. The flip-flop then, as the name suggests, flips and flops the two values. Now that the basic understanding of what's inside a Breadboard 555 has been explained, I will dive deep into how the diagram works. Before I do fully explain this diagram, I will be explaining it as if it's hooked up to a basic circuit, which can be seen on screen. Once the circuit is plugged in, we know that once power flows through the voltage divider, the first comparator, being the threshold comparator, will output a 0 or low, as 0 volts is not greater than 3.3 volts. But on the other hand, the trigger comparator will output a high, as 1.66 volts is greater than 0 volts. Therefore, the latch will be set, meaning that there will be an output of 1 and the LED will be turned on. When the output is high, the inverted output will be 0, therefore nothing will happen. Now, while all of this is happening, there's a key thing going on in the background, being the capacitor, which is charging. Once this capacitor reaches the voltage above or equal to 1.66 volts, the trigger comparator switches to emitting a low, doing nothing until the capacitor then reaches 3.33 volts. Once this occurs, the threshold comparator switches to emitting a high, which then triggers the reset pin of the flip-flop, resulting in a low as the output, turning the LED off. Now it gets interesting, as the inverted output will be high and go to ground, turning on the discharge transistor. Once this does occur, the voltage, instead of going to the capacitor, goes through the resistor and to ground, allowing for the capacitor to discharge. This, of course, creates a loop, in which the LED gets turned on and off, which can be seen on screen. Now I have a quick question for you guys. Would you guys rather build your own 555 or use the chip? I think me personally, I'll stick with the chip next time.